Our next witness is Mr. Todd Allen, who's a senior fellow, the Clean Energy Program for the Third Way. Dr. Allen, thanks for being with us, and you're recognized for 5 minutes, and please get the microphone up close.
Absolutely. Good morning, Chairman Whitfield, Ranking Member Rush, other distinguished members of the subcommittee. On behalf of Third Way, I greatly appreciate the opportunity to provide testimony on the importance of nuclear energy innovation. My perspective on nuclear energy comes from a diverse career. On my first job after college, I lived on a floating nuclear reactor as an officer in the U.S. nuclear submarine fleet. I spent 10 years teaching at the University of Wisconsin, nuclear engineering. I've seen firsthand a young generation that believes in nuclear technology as a critical component for providing clean energy. I've worked in the National Laboratory System as the Deputy for Science and Technology at the Idaho National Laboratory, working to open up the laboratory facilities to university and industry users across the country. Now I'm at a think tank, where I think. Third Way supports the further development of an innovation culture that creates and brings to market advanced nuclear technologies. Currently, nuclear energy is provided as a single product offering, specifically large gigawatt-scale electricity production machines. But the national energy system is changing rapidly, opening up the possibility of nuclear energy supporting a wider range of functions if new ideas can get from conception to commercialization. A 2015 Third Way report identified nearly 50 companies backed by more than $1.3 billion in private capital, developing plans for new nuclear plants in the U.S. and Canada. These companies are creating a growing number of product options of varying sizes and capabilities, intending to build upon the continued success of our current light water reactor fleet, which provides over 60% of the carbon-free electricity in the United States. Private-public partnerships will be key to the story, similar to the way hydraulic fracking and the Internet were developed and how SpaceX is currently teaming with NASA to send unmanned vehicles to Mars. So how can federal investments nurture this emerging culture of nuclear innovation? I'll use as an example a hypothetical graduate nuclear engineering student named Carla, who wants to provide clean energy to the world and make money at the same time. What's her path to success in transitioning a good idea on paper to a marketable product and a thriving company? And where can partnerships with the federal government be useful? First step, Carla would benefit from early interactions with technical experts, financiers, and business developers. We suggest Carla could be helped through the creation of private-public partnerships in early innovation, a proposal we have called innovation centers. Innovation centers would also benefit the Department of Energy by providing the agency with valuable information on private sector investment trends. They could then inform how DOE directs research dollars to solve problems that support multiple companies. Step 2, securing investments. At the Innovation Center, Carla has opportunities to troubleshoot and mature her concept. She's also introduced to financial firms, which ultimately helps her secure a small investment to fund her company. Carla could leverage her private investment to receive DOE cost share, allowing her to move quickly and to signal to investors that her design is especially promising. The Department of Energy already engages in cost share programs, like the ones currently supporting project agreements with Southern Company, TerraPower, and X-Energy, and further use of these is encouraged. Her third step, specialized testing. Here's where the federal programs become uniquely valuable, through access to national test beds. Some development requires access to specialized capabilities, for instance, test reactors, facilities to test radioactive materials, or high-performance computing. Fortunately, a number of the Department of Energy laboratories have these types of facilities and expertise that Carla needs. The Department of Energy created the Gateway for Accelerated Innovation in Nuclear, or GAIN program, to facilitate these private-public interactions. Step 4. Beginning her regulatory process. As she develops her technology, Carla would like to get signals from the regulator, short of licensing, that her technical solutions are reasonable. This will help her gain additional funding increments as she develops her designs. She needs a regulator who is staffed and funded in a manner that it allows it to be ready to respond to emerging light water reactor technologies. Ideally, the pace of regulatory review would support new products for an energy system that is changing rapidly, all while maintaining the traditional exemplary safety record. Step 5, demonstration reactor. As is typical with many new and capital-intensive technologies, Carla may need to build a demonstration of a reactor before moving on to a full-scale commercial reactor. To address this, the Department of Energy should allow innovators like Carla the chance to build their demonstrations at one of their laboratories that already have experience running nuclear facilities. Allowing Carla to build her reactor at Idaho or Oak Ridge, for example, could help her more affordably test her design and make any final changes to commercialize her product. Final step, NRC licensing of her demonstration reactor. Because Carla is hoping her demonstration reactor design will eventually be commercialized, which would require her to go through the NRC licensing process, it would benefit her if the NRC were involved in the licensing and construction of her demonstration reactor. When Carla's demonstration reactor works, she's ready to work with her investors and the Nuclear Regulatory Commission to get final design approval and funding for commercialization. Where can Congress help? Early innovation. Support the creation of multiple private-public innovation centers that facilitate the creation of a new generation of nuclear entrepreneurs. This could be formally done through report language in the appropriations process. Test beds. Support the GAME program as our National Nuclear Innovation Center, including ensuring a modern infrastructure with world-leading staff that serves as the nation's test bed. Ensure that federally supported R&D programs are structured to maximize value through well-structured private-public partnerships. And finally, regulation. Ensure that the Nuclear Regulatory Commission is staffed, structured, and funded to support a pace of regulatory review that would support new products for an energy system that is changing rapidly. House Resolution 4979 asks the NRC and DOE to look broadly at their functions and report back on how they could better serve this emerging nuclear innovation community. We're supportive of this national approach and have suggested some specific ideas. We hope DOE and NRC have additional useful ideas. We also appreciate the intent of the discussion draft from Mr. Kinzinger and are ready and willing to interact to optimize our ability to move nuclear technology forward. Thank you for inviting me to testify. I look forward to your questions.
Thank you. And our next witness is Mr.